In this example, we have a set of resistors that we're being asked to add together. If you recall, we have a set of equations we can look at. So we can either add resistors in series or in parallel. We need to establish which this is. If you follow the current I1 around, you'll see that at no point does the current get a choice to split off or split in half. So these are in series, meaning we're going to use this equation here. So R equivalent is equal to R1 plus R2, and we have 3 of these, so I'm going to add an R3. And so that will be 16 plus 22 plus 12. And if you add those together, you should get 50 ohms as our equivalent resistor. Now we could redraw the circuit to look like this. Let me redraw that resistor a little bit better. Where this is our 50 ohm resistor, this is 100 volts, and this is I1. Now I1 will also be going to this 50 ohm resistor. We're asked to determine what I1 is. So you can do a KVL around here, around I1, as that is the sum of the voltage around the loop is equal to 0. So we'll get, so let's go ahead and establish that we're going to have plus minus, because as this comes around, it's going to go down. So let's get our polarities. So we're going to get minus 100 volts, and then we're going to get plus the voltage to the 50 ohm resistor, all equal to 0. We can sub this out using Ohm's law. Minus 100 plus, in that Ohm's law, if you remember, is V equal to IR. So we're going to have the current I1 here, and our 50 ohm resistor equal to 0. I1 is our only variable left. We solve this, and we will get that it is 2 amps. Now we could go up here and prove that these are the same if you wanted to by doing the same thing. You would basically get 16I1 plus 22I1 plus 12I1 equal to 100. And then if you do that math, you'll get that the same thing. 50I1 is equal to 100.